This is question 2 taken from the June 2022 Cambridge International Advanced Exam. It's paper 2 booklet. So a curve has equation y equals to this function here, and you're asked to show that the x-coordinate of any stationary point on the curve satisfies this equation. You need to note that at stationary point dy by dx equals 0. So when we find the gradient of the curve here, we need to equate it to 0. How do we find the gradient of this curve? Well, we're going to have to apply the quotient rule to this. So if we let the numerator be u and the denominator be v, it means that by the quotient rule dy by dx, which is the gradient, is equal to v du dx minus u dv dx, all of that over v squared. So by the quotient rule, the gradient would be equal to this. So we're going to apply the quotient rule to this. So let's write it down here. So we have y equals to, we have y equals to 9 e to the 2x plus 16. So dy by dx is v, so remember this is u, that's u, and that's v. Hence we would have v, which is e to the x minus 1, that's v, and du dx, when we differentiate this, we get 18 e to the 2x. Minus u, which is 9 e to the 2x plus 16. When we differentiate the denominator here, e to the x minus 1, we're going to get just e to the x. When you differentiate this, 1 times e to the x is just e to the x. All of this over v squared. V here is e to the x minus 1. All squared. Okay, so we just need to tidy up this now and equate it to 0, because at stationary dy by dx equals 0. So if we equate this to 0, it means that we would just have the numerator equals to 0, because this would become 0 when we times both sides. So here we have, we can just distribute this now. So we're going to have 18 times 18 e to the 2x times e to the x is going to give us 18 e to the 3x. 18 e to the 2x times minus 1, there is just 18 e to the 2x. And let's distribute this now by minus e to the x. So minus e to the x times 9 e to the 2x is going to give us minus 9 e to the 3x. And that would be minus 16 e to the x. And that equals 0. So what we need to do is to simplify this form to get what they require here. So 9 e to the 3x from 18, that's going to give me 9 e to the 3x. And then we're going to have 18 e to the 2x minus 16 e to the x, and that equals 0. We can factor out e to the x here. So that's going to give us 9 e to the 2x minus 18 e to the x minus 16, and that equals 0. Now if you notice inside the bracket here, we can write this as a quadratic equation, because if I just write it, let's just use a different color ink. Let's use this ink here. So what is in the bracket here? So we can have 9 e to the x squared minus 18 e to the x minus 16, and that equals, put that in bracket, and we have our e to the x outside here. So this is in quadratic form, so it means that we can factorize this. So we would have our e to the x outside the bracket there. 3 e to the x and then we want to get minus 16 as the factor there, and the sum should be minus 18. So if we have minus 8 here and positive 2, that will give us, yeah, that's right, yes, so that's correct. So it means that we have now written it in the form as required. So we have completed part A of the question. Now let's look at part B. It says, hence show that the curve has only one stationary point and find the exact coordinates. So we're going to use the answer from part A here, the solution here, to prove that. So what we had there before was e to the x into 3 e to the x minus 8 into 3 e to the x plus 2, and that equals 0. So what we need to do is to find the solution of x here. So e to the x equals 0. If we should solve for x here, we can't have the log of the ln 0. So x here would equal to ln 0, which does not exist. So this is not a solution. This is impossible. Okay, then we have 3 e to the x minus 8, and that equals 0. Now we can solve for x here because it's positive. So it means that we would have so e to the x there would equal to 8 over 3. So to get x, we take the exponent both sides, we take logs both sides, so it means that x would equal to ln 8 over 3. And for this one, 3 e to the x plus 2 equals 0. If we should solve for x there, we're going to get a negative, so this is impossible. So that's not possible. You can't solve that, so that's not, it's not possible. Because if we have, we can just show you what's going on there. So we're going to have 3 e to the x equals to negative 2. So we can't have a negative ln x, ln value. So it means that that's not possible. So the only solution is this one, which is what they had asked for. Okay, now so we get the x value, so they want the coordinate, the exact coordinate. So the x value here is ln 8/3, so we need to get the y value now. So from the function here we have y equals to 9e to the 2x plus 16, all of that over e to the x minus 1. So if we input the value of ln, so what we have there is y equals to 9 e to the 2 ln 8/3 plus 16, all of that over, I'm going to just show you what's going on there. So we have e to the ln 8/3 minus 1. Now if you have e to the 2 ln 8/3, it means that we can write 9 times 8/3 squared plus 16, all of that over 8/3 minus 1. And what we get there at the top is that would be 64, and then that's 9, so that goes out. So 64 and 16 is 80, and then 1 from 8/3, which is just 5/3. Yep. So what we get there is 48. So y is 48. So it means that the coordinate would be ln 8/3 as the x value, and the y coordinate there is 48. Here ends question 6. Thank you.